Virology, or HPV, is one of the members of the subfamily of papovaviruses. Each two letter of the name of papova is coming from one of the members. Pa is for papilloma, po is for polyoma, and va is for vacuolating. The signature of this family is the double-strand DNA, which is circular, and also they are naked. Naked means they are not having envelope, and they have a isohedral nucleocapsid. Their genotype, they are very diverse, having nearly 100 genotype, and they are the causative agent of the condylomas, papillomas, and the warts, and they can affect the larynx, pharynx, and the urogenital area and the anus. So and now we're going to discuss about their genome. Their genome has a URR, which is upstream regulatory region. So this upstream regulatory region is where the transcription factors are going to attach to it. Then the genome has two kind of parts, the two genes. One of them is the late gene, and the other is early gene. So late gene is the structural one, and it will be transcribed after the early genes. And because they are structural, we first needed the replication and all of the factors we need, and then we can go to the structure so we can form the eventual the terminal virus. So we first need the non-structural ones. We need to transcribe the non-structural ones, which are early, and then we can go to the late ones. So the non-structural ones are E1, E2, no E3, E4, E5, E6, and E7. Now we're going to discuss about their parts. E1 is the one that the DNA polymerase is going to attach to it. So E1 is the place that DNA polymerase is going to attach to it. E2 is the regulatory region for E6 and E7. It actually downregulates them, means the E6 and E7 in a normal condition are going to be transcribed, but this E2 is going to downregulate them, means inhibit them. And E4 is the regulatory region for E1 and for L1 and L2, which are structural ones, but in normal condition, because they're late, we don't want them. And but E4, because E4 is early gene, so first the E4 as early gene has to be transcribed, then it let the L1 and L2 to be transcribed. So it up-regulate them. And we have E5, which stimulated the cell proliferation, because the more we have cell proliferation, the more replication of the virus is going to happen, because this virus is inserted inside the genome. So the more cell proliferation, the more viral proliferation. And then we have E6 and E7. The E6 is going to inactivate P53, and E7 is going to inactivate PRB. But what are these P53 and PRB? They are the inhibitory factors for cell proliferation, because when the cell wants to be proliferated, first it is in the the cell is in the G1 level. It has to go to the S phase, which the genome is we have one gene, so it has to be 2. In the S phase we have the proliferation, and we will have the replication. So when we have DNA damage, like from the UV light, or the cell is infected with a virus, the DNA is going to tell the P53 and PRB and tell them, hey, I'm damaged and I don't think that you need another copy of me who is damaged. And these P53 and PRB are going to say, okay, we're going to inhibit this process, so we won't let the cell to go from the G1 to S phase, or enter the S phase so we make another copy of these damaged DNA. But what E6 and E7 are going to do, they will say, okay, we know that we have affected the cell, so the cell doesn't want to be replicated, but we are going to affect this P53 and PRB, so the cell will do the replication, and DNA cannot tell anyone that I'm damaged. So the E6 is going to affect the P53, so it can't go and affect this replication, and E7 is going to affect the PRB. That's how the E6 and E7 are going to inhibit those inhibitory factors who are P53 and PRB. So the tropism means the cells that a virus is going to affect. What kind of cell does it like? Where it wants to go is a squamous stratified epithelium, means this, and stratified means many layer of the epithelium, because the way it's going to grow and to replicate depends on this many layer thing. And actually the tropism is for the squamous. And where do we have this squamous stratified epithelium? In the urogenital area, and also in the larynx and pharynx. And the places it's going to affect male and female is kind of different. Why? Because the urogenital area is kind of different. So but for both of them is the outer reproductive system and the anus. So for the male is shaft of the penis and around the anus, and for female is vagina, vulva, and cervix, which are the beginning of this uterus. And it also later can affect the cancer in these tissues: anus, penis, vagina, oropharynx, and the larynx. Now we're going to talk about how these virus is going to start its journey. The first phase, or the first place that the virus wants to go and use as the reservoir, it means the place that is like a store for the virus, is a stratum basale, or the first place of the first layer of the skin. So the reservoir is this, and in this first level it affected the DNA polymers of the cell to work more, so we will have more replication, and as a result we will have more HPV replication because it's already in the genome. And then when the virus wants to go to the supra-basal layer, it starts to act more E6 and E7, which can cause the more replication of these E6 and E7. So we will have again more cell replication, and again we are going to go to the next level, which is the granular layer. in the granular layer, we will have another phase by E2 and E4. E2 job was to downregulate E6 and E7. So the E6 and E7 who was so effective in the supra basal layer and the basal level are going to be downregulated, so the cell proliferation is going to be less. And now E4, whose job was upregulating the structural proteins such as L1 and L2 for the capsid, is going to upregulate this L1 and L2. So we will have more capsid maturation. So the viral genomes who has been made in the suprabasal layer during the replication phase are going to be packed inside this capsid, so the new viruses are going to made. And then when the virus goes to upper levels and on the surface of the skin or the stratum corneum, the virions are going to be released from the cell. And how they are going to be released? By the desquamation of the most superficial layer, which is the corneus level. So the desquamation is going to happen, and as a result we will have the warts, condylomas, papillomas, which are benign. Why they are benign? Because of the existence of E2 doesn't let these E6 and E7 which as a result into E6 and E7 to be downregulated. So as a result cell proliferation is going to be downregulated. But if they are benign, so what will make it a carcinogen or a virus that can cause cancer? The genome, as we said here, we mentioned that we have a circular DNA, but our genome in human is linear. So when the circular genome is going to be inserted inside the linear genome, it has to be cut. Where this cut happens between the E2 and E4. E2 and E4 are having some overlapping, so the part of the E4 gene is going to be another part, and part of the E2 genes are going to be in another part. So it's going to be a linear genome that E2 and E4 are destroyed and not complete in each side. So we will lose actually the E2 and E4 genes, which were the regulatory ones and the good ones. The thing is, when the E2 is destroyed, so E6 and E7 are going to be more made, and we will have more cell proliferation as a result. But E4, who was upregulating L1 and L2 is going to be destroyed, so we won't have the cellular the virus structural proteins anymore. And the point about the papillomavirus is that the less cellular particles is made, it's more severe. Like the less here, as we say, the less L2 and L1 are produced, it is more severe. And also the way of a transmission of this virus is STD virus. HPV is STD, as you know. It's with sexual transmission, and we have vertical transmission, means from the mother to the children, and the urogenital disease in the mother can cause the newborn larynx disease. So we have two kind of genes in the genus of these papillomavirus. One of them is alpha and the other is beta. Beta one is for the skin and can cause warts, and the most severe ones are 1, 2, 3, and 10. I can say 3 and 10, but also we have 6 and 10 here, 6 and 11 here, but the severe ones are 1, 2, 3, and 10. And also this beta form can be a usual skin flora, not necessarily causing disease. And the alpha genus is for the mucosa, and it has 40 types. The most severe ones are 16 and 18, which has the vaccine. And we have another one, which is gamma genus. For the diagnosis, we use pop test, but first we can say we have two kind of diagnoses. One of them is a direct, which we are searching for the virus itself directly or its particles directly. The indirect is for antibodies which has been attached to these particles, so we are indirectly searching for these antibodies, and we are using pop test, which is cervical swabs, and it's 25% wrong, and it is also indirect one because we are not searching for the virus itself but the antibody, so it is the indirect one. And we can also improve the sensitivity of the pop test by acetic acid solution test. So we can use acetic acid solution to make it more sensitive. And for the genotype diagnosis, because we are facing the severe ones or the carcinogenic ones, or also the ones who are skin flora, so we have to know which kind of papillomavirus we are looking for. So we are having, so we are using PCR, which is a HPV DNA test with amplifying the genotypes to understand which kind of virus we are having. And for the vaccine, first of all, we have to know that not all of the genotypes have the vaccine, but for the vaccine we are using empty capsid of this virus, which is called virus-like particle, or VLPS. This and the capsid we said is made of L1 and L2, but we are using L1 as the empty capsid, or VLP. The vaccine can be bivalent, that we use 12 and that is against genotype 12 and 18, or it can be tetravalent 16, 18, 6 and 11. And it's important to note that not all the types of papillomavirus has vaccine.